The goal of this video is to define power in terms of work and forces. Power is defined simply as work performed over a time interval. Therefore, power has an instantaneous definition as the derivative of work with respect to time. The dimensions of power is a joule per second, which we call a watt. You may already be familiar with the unit of a watt. Electrical appliances and devices often come with power ratings, listed wattages. An old incandescent light bulb may have a power rating of 100 watts. That means if you leave the light bulb on for an hour, or 3600 seconds, the light bulb will perform 360 kilojoules of work. If you've ever read an electricity bill, however, you'll know that you are not charged by units of watts, but by units of kilowatt hours. A common rate might be 12 cents per kilowatt hour. A kilowatt hour is a unit of power multiplied by a unit of time, meaning a kilowatt hour is better thought of as a unit of work than of power. If you leave your 100 watt light bulb on all day, it'll perform 8.6 megajoules of work, which at a rate of 12 cents per kilowatt hour would cost you about 29 cents. Compare this to a modern dishwasher. A typical new dishwasher has an average power rating of about 1800 watts. If you let your dishwasher work an hour, it'll perform 6.5 megajoules worth of work. These machines typically run in cycles that are 2 hours long on average, so running this dishwasher would result in 13 megajoules of work being performed, at a cost of about 43 cents. Of course, older dishwashers are much less power efficient and could easily cost closer to $1 per run. Power is the derivative of work with respect to time. Work is defined as force dotted with displacement, so dW is F dot dx. dx dt is the definition of velocity, so we can also calculate instantaneous power as a force multiplied by an instantaneous velocity. As an example, a medium-sized sedan has a drag coefficient somewhere around 0.30. Driving at about 25 meters per second, which is about 56 miles per hour, this corresponds to a drag force of 187 newtons. Therefore, to maintain the vehicle at this speed against the wind in front of it, a car engine would need to work at a rate of 4,700 joules per second, or 4.7 kilowatts.